Another one, data processing here. Because processing, big data processing here. Okay. Yes. So big data challenges. So what are the big data? Today topic is big data challenges. So what are the challenges from the big data? Let us see one by one here. So first is data storage, next data processing, data processing. So another one is data processing. Okay. So data storage, data processing, next high-end hardware required for the big data here. High-end hardware. Yes, high-end hardware required for the big data here. So next, chance of generating very large files, very large files, very large files. Okay, chance of generating very large files. Okay, right? Yes, next, backup, backup and recovery, backup and recovery, backup and recovery. Yes, next, disaster management, disaster management, disaster management. Okay, the DR active disaster recovery. Right, okay. Yes, these are the main challenges we big data. Yes, apart from these other challenges also, these are the main challenges. They are primary challenges. Yes, other challenges we'll discuss next year. So these are the main challenges. Okay, big data storage, data processing, high-end hardware. Yes, very large files, backup and recovery care, disaster management. Yes, traditional systems, traditional database servers, traditional database servers like Oracle database server, MySQL database server, Microsoft SQL server. Like this, we have many traditional database servers. All these traditional database servers, all these traditional database servers are not in a position to store this much of data, right? Okay. Yes, these traditional database servers are not in a position to handle all the challenges. Okay. Your traditional database servers like Oracle, Oracle database server or Microsoft SQL server, something like this. These servers, data storage. Yes, they can't store huge amount of data. Data processing. Yes, big data processing short term. No, they cannot. They can't process it. With traditional systems, high-end hardware required here. So it's not easy here. Expensive hardware, right? Very large files. Traditional systems cannot handle very large files. Backup. Yes, it's a risky task. Backup and recovery is risky task with traditional systems. Next, disaster management. The DR Act is a risky task. Okay. Yes. So which is the best technology to face all the challenges? Yes, which is the best technology to face all the challenges here? Yes, Hadoop. Hadoop is the best one. Hadoop is the solution for this. Yes, Hadoop is the solution for all these big data challenges. Yes, Hadoop is the solution. Yes, Hadoop provides best solution. Okay, Hadoop is a solution to face all the challenges. To face all the challenges. All the challenges. Okay, to face all the challenges. Right, okay. Yes, Hadoop provides best solution. Yes, Hadoop provides best solution. Hadoop is the right technology to face all the challenges. It provides best solutions to face all the challenges. Let us see one by one. First about data storage. Data storage. What is solution from the Hadoop here? Data storage. Okay. So first, yes, in all cases here, yes, sir. Data storage, data processing, high-end hardware, very large files, backup and recovery, disaster management, all the cases here. Yes, how traditional systems handling this? Okay, traditional. Yes, traditional. Yes, traditional databases, traditional databases versus Hadoop. Let us see that versus Hadoop. Yes, traditional databases like server. Yes, MySQL database server. Okay, Microsoft SQL Server like this. These all are called traditional databases. Traditional databases. Existing databases are called as traditional systems. Okay, existing databases are traditional systems. So since last 20 years we are using these database servers, right? Those are called traditional systems. Okay. So whatever the softwares we are using since last 20 years, those are called as traditional things. Means existing one. All existing database are traditional database. Yes, new is Hadoop, right? Hadoop is a new one here. Okay. Now let us see traditional database versus Hadoop here. So first about data storage. First about data storage. Okay, let us see about data storage. Data storage. Yes, data storage. Yes, in traditional system. Yes, how data storage? Let us say about data storage. Okay. Yes, traditional database server. Yes, this is database. Okay, database server. Okay, suppose initially yes, initial database server capacity, yes, maybe, yes, something, maybe some 10 TB. So initially database server capacity, yes. So here at the time of installing database server, yes, that is configured with some 10 TB here, 10 TB server here, right? Suppose initially database server, okay, yes, for example here Oracle database, okay. So Oracle database server, Oracle, yes, database server, let us take it. What Oracle database server, let us take it. Okay, so Oracle database server with capacity 10 TB, initially with capacity 10 TB, right? 10 TB, right? Suppose here, yes, here daily generating some transactions. So whatever data generating, that is storing database server, right? Okay, see here application. For example, let us take some application here, some web application. Let us take some web application. So this is database server. So it's a database server. So this is database server, database server, database server. Let us take application also. Let us take some application. Suppose web application. This is, so this application. Okay. So this is some web application, maybe Facebook application or Flipkart, something like this. Some web application. Okay. So web application connect to database. So web application connect database, the storing data in database. Right, okay. Yes. So first here data, all the data generating from the users. Suppose user browser. Let us take some browser here. Suppose this is browser, end user browser. Suppose this is browser. For example, this is browser. So browser. So whatever data is generating here, that is from the browser. Yes, browser data. User uploading data into web application, right? So for example, Facebook application. Yes, every day we are uploading some data, right? So from your browser. So whatever data uploading, the data simply goes to web application. From web application then goes to database server, right? So this is web application architecture is like this. Web application is like this. Okay, web application is browser data. So whatever data we are uploading, the data first of all goes to application. Yes, this application may be Facebook application. This application is something here. Yes. So this application, that web application, may be Flipkart application or Amazon. So, Amazon online shopping here, something like this. Maybe Durga website. Yes, maybe Facebook application, some web application, right? So first browser data. So whatever data we are uploading. So first of all, this data goes to web application database, right? So this web application every day is generating some data, right? So but database server initially capacity 10 TB. Suppose initially, yes, initially capacity database server is set up with 10 TB capacity. So initially capacity 10 TB, right? Okay. So here, yes. So daily here generating some data, the data stored into this database, right? Yes, after some time. Okay, at some particular point of time here, this database server failed. Then database admin, the DBA, database admin. Yes, DBA. So database admin, yes, you will add one more disk. Yes, increasing volume. Yes, DBA you will increase. Yes, you will increase. Yes, you will increase volume of. Yes, you will increase the volume. Just increasing volume of database server. Right? You will increase the volume of database server. Increasing capacity. Suppose initially 10 TB. Okay. Yes. So for this 10 TB here adding, yes, 2 TB disk. Maybe adding 2 TB disk. Means it's a 12 TB, right? 12 TB. Suppose this also filled. Yes, adding next one more disk with 2 TB capacity means 14 TB, right? Suppose this is filled. This is filled here. Then you will add one more 2 TB here. Like this, continuously adding disk like this plus 2 TB like this. So like this, increasing capacity of that database server, that is increasing capacity of database server, right? Okay, see here, let me explain very clearly here. Yes, in real-time production servers, yes, how DBA will maintain all the production servers. Yes, about production servers we'll discuss this. About production servers, how DBS will manage, yes, all the production servers. Now this is vertical scaling, not horizontal scaling. Yes, Hadoop is a horizontal scaling, it's a vertical scaling. Yes, that scaling, yes, same topic I'm going to discuss, same topic I'll be discussing. Just wait. Suppose for example here, yes, let us for example, suppose initially, yes, initially database server, DB server, database server, yes, installed with 2 TB capacity, 2 TB capacity, right? Initially 2 TB capacity. So once 2 TB filled here, next one we adding one more disk. Okay, then increasing size of this. Suppose again filled here, again increasing. So continuously increasing this. Okay. Now here, how they will increase all this size here? So for this purpose, yes, see here, generally our computer, yes, let us take computer. Yes, in computer, yes, there's a motherboard. In computer there's a motherboard. Okay, there's a motherboard. So this motherboard, so here motherboard, yes, this is with motherboard with, yes, 12 slots. Motherboard with 12 slots. There are 12 slots in motherboard. Okay, every motherboard contains 12 slots. There are 12 slots. Okay, so default motherboard 12 slots, or this is called LANs. 12 LANs. Slots or LANs. Anyone you can say here. Okay. Yes, initially here, yes, DBA, just you will install database server with 2 TB capacity, 2 TB disk. Just initially with 2 TB disk. Yes, 2 TB disk available in the market. 2 TB disk, right? So once 2 TB filled here, then he will add one more 2 TB. Suppose this is filled here, then adding one more 2 TB. So like this, he will increase the capacity of that. Yes, capacity of database server. Like this, he will increase capacity of database server. Yes, 2 TB, 2 TB like this. So here, how many here? Totally 12 LANs. 12 LANs means. So what's the maximum? This is 12 multiplied by 2 TB. So this value is equal to 24 TB, right? Up to 24 TB, you can increase the volume of this, right? Okay, just increasing capacity like this. Okay, yes, here there are 12 LANs. So initially started 2 TB, next 2 TB, next 2 TB. When filled here, next adding next 2 TB disk. Just you will connect one more disk. Okay, yes, the disk capacity 2 TB disk. So first initially one disk connected. So you get 12 slots. Yes, in 12 slots, first slot 2 TB disk. Suppose that is filled. Yes, you will add one more 2 TB disk. 2 TB disk. Suppose this is filled. One more 2 TB disk. Yes, suppose this also filled. Next one more, another one like this. Like this up to 12. Up to 12, right? That means 12 into 2 TB is equal to 24 TB. So this maximum capacity is what here? 24 TB, right? Okay. Suppose still data is there, still data generating here. Then how to increase volume of this? Okay. So you can compare it with motherboard, right? Motherboard with 12 slots, right? Yes, instead of this one here. Now, yes, purchasing motherboards. Then we'll purchase motherboards with 24 slots. Yes, 24 slots. This type of motherboard is available in market here. So motherboard with 24 slots. Motherboard with 24 slots, right? Yes, if it is 24 slots, then how much space here? Yes, 24 multiplied by 2 TB is equal to how much here? Yes, 48 TB, right? 48 TB. 48 TB, right? Okay. So 24 multiplied by 2, it's a 48 TB. Okay. So maximum is up to 48 TB, right? Suppose still data is there, then yes, that company can go for high-end systems. High-end system. Yes, high-end system. So what is that high-end system here? High-end system. Yes, company they can go for high-end system. Yes, high-end system. Yes, it can have. Yes, it can have two motherboards. It can have two motherboards. It can have two motherboards two motherboards with yes, with each 24 slots. 24 slots. Okay. Yes, it can have high-end system. It can have two motherboards with each 24 slots. 24 slots. That means 24 multiplied by 2 is equal to 48 slots, right? So it's a 48 slots, right? Okay. Now 48 slots multiplied by 2 TB. See here, two motherboards, each 24 slots, right? So two, yes, two motherboards, each 24, 2 into 24. Yes, this is the two motherboards with each 24 slots, totally 48 slots, right? Then 48 slots, 48 into, yes, multiplied with 2 here. This value is equal to 96, right? So this is 96 TB. Yeah, this is a very high-end system. It's a high-end system, right? It's a high-end system. Okay. Still data is there. Yes, company can use very high-end system also. Very high-end system. Very high-end system. So what is this very high-end system here? Yes, instead of using 2 TB disk. Yes, here 2 TB disk, right? Instead of using 2 TB disk here, 10 TB disk. Yes, in market 10 TB disk is available. Just using 10 TB disk. Suppose if it is 10 TB disk, then what's the maximum data here? 10 TB disk. If it is 10 TB disk here, 48 slots multiplied by 10. So this value equal to 480 TB, right? This is very high-end system. Very high-end system, right? So like this, yes, increasing capacity of disk. Just DVS, they will increase the capacity of disk. Right? Okay, just increasing volume of this here database server. Okay, so so initially starting some 10 TB, so next adding next 10 TB, next adding next 10 TB, 10 TB like this, yes, increasing capacity, right? So initially, yes, like database server capacity here, maybe 10 TB, right? So once this volume is filled here, then increasing capacity of this, yes, still data is there, increasing capacity, next increasing capacity, once filled again increasing capacity here, once filled here again increasing capacity, once filled increasing capacity, like this, increasing capacity, right? Increasing capacity like this. Okay, so this type of, yes, this type of increasing, this type of increasing capacity here, this is called as vertical scaling. So this is called as vertical scaling. Vertical scaling, this is called as vertical scaling. Okay, traditional systems always follows vertical scaling. So what is vertical scaling? Yes, it's a process of increasing volume of the server. Yes, it's a process of increasing, just increasing volume of only one server here, called as vertical scaling here. Okay, so vertical scaling. So what is vertical scaling? It's increasing, yes, increasing, yes, increasing volume, yes, or increasing capacity, yes, capacity of server, increasing capacity of server by adding disk, by adding, yes, disk, by adding, yes, disk, by adding this, right? Okay, so just it's increasing capacity of server is called as vertical scaling. So here all traditional systems always follows vertical scaling. Traditional systems always following vertical scaling. Traditional systems is a vertical scaling. This is data storage in the traditional systems. Okay, see, our topic is traditional systems versus Hadoop here. Here data, first data storage. Traditional systems, traditional database versus Hadoop. Yes, in traditional systems, data storage. First data storage. Data storage, suppose if it is Oracle database server or MySQL database or Microsoft SQL server, you take any database server, just increasing. So just increasing capacity of that server, increasing volume. So increasing capacity of server. So this is called vertical scaling. So traditional systems always following vertical scaling. This is way of increasing capacity of servers. This is in traditional systems. Okay, same scenario. Let us see Hadoop. Okay, same thing. If it is Hadoop, what happens in case of Hadoop here? Okay, yes. Let us see Hadoop. Yes, Hadoop. Yes. Let us see about Hadoop here. So first of all, what is Hadoop? First question is, what is Hadoop? So what is Hadoop? First question is, what is Hadoop? Yes, simply answer for this. Answer for this. Hadoop is a framework. Hadoop is a framework. Framework means ready-made one, ready to use. Framework meaning ready-made one, ready to use. Okay. Yes. How do we say framework? To store and process big data. To store and process big data. How do we say framework? Yes. How do we say framework? To store and process big data. How do we say framework? To store and process big data. Okay, it's a framework. Just it's a framework to store and process big data. Yes. Okay. Yes, in Hadoop, basically two modules. There are two modules. There are two modules here. In Hadoop, there are two modules basically here. There are two core modules. They're called as core modules. There are two modules. Two modules. So these are called as core modules of Hadoop here. Core modules. Yes, apart from the core modules, we have other modules also. Yes, other modules we'll see next here. There are two modules. Basically, there are two modules in Hadoop here. First one is HDFS. First one is HDFS. Second one is MapReduce. HDFS and MapReduce. So these are the two modules in Hadoop here. These are the core modules. There are two modules. These are called as core modules. One is HDFS. Another one is MapReduce. So what is HDFS? What is MapReduce? Let us see one by one here. So HDFS. So what is HDFS? HDFS stands for Hadoop distributed file system. Hadoop distributed file system. Yes, HDFS stands for Hadoop distributed file system. Okay. Yes, here HDFS. Yes, it is like a backend. It is like a backend, backend to store the data here. To store big data. To store big data. Yes, HDFS is a file system. Yes, HDFS is a file system. It's a distributed file system. What is distributed file system? We'll discuss next. Wait. Yes, HDFS, Hadoop distributed file system. It's a file system, like a files, like a Linux files, like a Windows files. In Hadoop also file system is there. Yes, Windows files storing some data, right? In Windows files we can store some data. Like that in Hadoop files also we can store data here, right? But using for the big data storage. This HDFS using for the big data storage. Okay, so HDFS Hadoop distributed file system. It is like a backend to store the big data. To store big data, right? Yes, next step. Yes, MapReduce. Yes, what is MapReduce? MapReduce. Yes, here is Java programs. So MapReduce, these are Java programs. Yes, these are Java programs. These are Java programs to process. Java programs to process big data. To process big data, right? So you can how HDFS is like a backend. MapReduce is like a front end here. Front end. See, take any application. Yes, any application is a front end, back end, right? For example, traditional applications. See, traditional application here. This is back end, right? To store data. Back end storing data, right? Back end using for data storage, right? So it's a back end, right? Next here, application. Yes, forms. Yes, application form reading data from clients, users, the storing database, right? So this is kind of front end. Yes, application that forms, maybe registration form. Okay, maybe whatever that form here, all that forms, it's a front end, right? So application is a front end. Okay, data is a back end, right? So this is front end, this is back end. Okay, like this in Hadoop also is a front end, back end here. Okay, see in traditional systems this application is a front end. Okay, database is a back end. So back end is to store the data. This application is to process data. How that data processing? Application taking data from the browser, then storing the back end, right? Next, vice versa. Suppose for example, yes, in Facebook, yes, your account registered the registration form, right? Filling registration form. Once it's submitted, the data goes to application. Application taking your all the information, then yes, storing database, right? Once storing database, successful registered message getting, right? Yes, done. After that, suppose when you click on profile, yes, your profile request, that request goes to application go to database and collecting all the data here, then present to you, right? So this application is processing data, right? Yes, your request processing. Okay, your request maybe registering ID here. maybe profile information getting here, something like this. So this is processing your data, right? So application, this is like a, yes, a front end to process data here. Yes, back end, this is to store data. So any application, yes, take web application or any kind of application, is a front end and back end here. Back end is to store the data, front end is to process data, right? Back end is to store data, yes, front end is to process data. Yes, like traditional systems, yes, in Hadoop also, data storage and data processing, in Hadoop. Okay, yes, HFS is for the data storage. Okay, HFS is a file system, is like a backend to store big data. Next, MapReduce, they are the Java programs like this. Yes, like web application, all the programs, right? Okay, programs, different kind of programs like registration program here, registration program, yes, maybe, yes, profile submission program like this, all the programs, these web application programs like that here also. Yes, there are programs here. MapReduce, yes, all these are programs here. MapReduce, they are Java programs to process big data, right? So this is like a front end. So MapReduce, yes, working like a front end, here. It's a front end. Okay, so MapReduce, so like a front end. So these are working like a front end, right? Okay, so HDFS and MapReduce. Yes, in Hadoop there are two modules here, HDFS and MapReduce. HDFS, it's a file system to store the data like a backend. Yes, HDFS, it's a file system to store the data like a backend. MapReduce, these are the Java programs to process data like a front end. So HDFS like a backend, MapReduce like a front end here. So this is HDFS, it's a backend. MapReduce front end. So HDFS storing data, MapReduce processing data here. So here is a big data. This is dealing big data here. HDFS to store big data. Yes, MapReduce to process. Yes, big data, right? Okay. Yes, let us see about HDFS here. See HDFS, Hadoop distributed file system. So first of all, what is distributed file system? Let us see this. What is distributed file system? Your question is, yes, what is distributed? What is distributed file system? Distributed file system. Let us see about distributed file system. What is distributed file system? Yes, about this. Okay, so DFS. What is DFS? See, in distributed file system, file, yes, file splitting into multiple parts. Okay, yes, in DFS, file splitting into multiple parts and storing on multiple systems. Multiple systems are computers. Multiple computers in a network. Yes, in a network. Okay, so this is called distributed data storage. So first of all, file splitting into multiple parts. Just a file splitting into multiple parts. Yeah, those parts are storing on multiple computers in a network. So one file storing on multiple computers in network. That is called distributed data storage. Okay, distributed file system. Just only one file. Yes. So one file storing on. So one file storing on multiple computers. So one file storing on multiple computers in a network here. That is called distributed data storage. So just only one file storing in, yes, multiple computers network, right? So this is called distributed file system here. So here in distributed file system, DFS, distributed file system, file splitting into multiple parts, multiple parts and storing on multiple computers in network, right? In a network. That is called the DFS concept, distributed file system. So one file storing on multiple computers network, right? Suppose if it is traditional system, a traditional file system. See, let us take traditional file system. Yes, Hadoop following DFS concept. Hadoop distributed file system. Hadoop following DFS concept, distributed file system concept here. That means in Hadoop, one file splitting into multiple blocks. In Hadoop, one file splitting into multiple parts here, multiple parts, and storing on multiple computers network, right? That is Hadoop, yes, file system. Yes, when come to traditional file system, yes, traditional file system, traditional traditional file system, yes, like Linux file system, Linux or Windows file system. Yes, Windows file system, Linux or Windows file system. These are the traditional file systems. Traditional, traditional file systems like Linux and Windows file systems. Yes, in these file systems, in traditional file systems, in this file systems, in this file system, one file, one file storing, yes, one file storing always in one system only, not on multiple systems. One file storing on only one system, only one system, only one system, not multiple systems. Okay, but not multiple systems, not multiple systems here. So multiple systems. So this is not multiple systems here. It's not multiple computers. Okay. So one file. Yes, in traditional file system, Linux, Windows file system here. Yes, in this file system, okay, one file storing on only one computer. So only one computer, not multiple computers here, but not multiple computers, not multiple computers. Okay. Yes, in DFS, in distributed file system, here, one file splitting into multiple parts. One file splitting into multiple parts. Yeah, that parts storing on multiple computers network. That is DFS concept. Okay. So in DFS here, yes, file splitting into multiple parts or storing on multiple computers in network. Right? Okay, network storage. Okay. Yes, one file storing on multiple computers in network. Yes, when come to traditional file systems like Linux, Windows file system here. Yes, in this file system, one file storing on only one computer, but not multiple computers. So always storing only single computer. So this is storage. Yes, traditional file systems like this and DFS like this. Okay. Yes, now come to Hadoop, HDFS. HDFS, Hadoop distributed file system. Yes, in HDFS, how it's working? Let us see about HDFS here. Yes, yes, in Hadoop, yes, in Hadoop file system, in Hadoop file system, okay, yes, a file splitting, splitting into multiple blocks, splitting into multiple blocks. They are called as blocks here. Multiple blocks, okay, multiple blocks, and distribute these multiple blocks. Okay, yes, a file, yes, splitting into multiple blocks and distributing, distributing onto, distributing, distributing onto multiple, yes, multiple computers in the Hadoop network here. Computers in the Hadoop network called as cluster. Hadoop network, Hadoop network called as cluster here. Hadoop network is a Hadoop cluster. Okay, Hadoop network called as cluster. Hadoop network or cluster here. Hadoop cluster. So this is Hadoop network or cluster here. Hadoop cluster. Hadoop cluster. Right? Okay. Yes. In Hadoop file system, a file splitting into multiple blocks. What is block? We'll discuss. Okay. And distributing onto multiple computers. Those blocks are distributing onto multiple computers in the Hadoop network. Called as the cluster. It's called as cluster, right? Okay. So what is block? Let us see about what is a block here. What is a block? Okay. Yes, in every file system. So what is a block? So let us see. What is a block? Yes, in every file system. In every file system. Yes. Here maybe Linux file system. Okay. Yes. In every file system. Yes, that could be. Yes, that could be Linux file system. Linux or Windows. Okay. Or Hadoop. Linux file system or Windows file system or Hadoop file system. Okay, in every file system, that could be Linux file system or Windows file system or Hadoop file system. Hadoop file system. Yes, in every file system that could be Linux or Windows or Hadoop. Yes, any file system here. In any file system, yes, hard disk. That hard disk. Yes, yes, in every file system here. Yes, you take any file, every file system, maybe Linux file system, Windows file system, Hadoop file system here. Yes, all the data storing, yes, storing into hard disk. All the data storing disk, right? Hard disk. Yes, here hard disk. What is the purpose of hard disk? To store data permanently, right? Permanent storage. Yes, in your system there is a RAM and hard disk, right? RAM and hard disk. RAM is to process data, hard disk is to store the data. Yes, in every file system, yes, that could be Linux file system or Windows file system, Hadoop file system. Right? All data storing into disk, right? All data storing into hard disk. Just storing into hard disk, right? Just storing into hard disk. All data storing into disk. Storing into disk, right? Yes, here hard disk and RAM. So what is hard disk? What is RAM here? RAM is to process data. Hard disk is to store the data. Hard disk, hard disk is to store the data. RAM is to process data. Right? Okay. Yes, here hard disk. Yes, about hard disk. Let us see about hard disk here. Hard disk. Every hard disk. That file system may be anyone here. Okay. Yes, any file system. In any file system. Okay. Yes, in any file system. Yes, in any file system. Yes, any file system. Yes, hard disk divides into divides. Hard disk divides into multiple blocks. That hard disk will be divided into multiple blocks. Divides into blocks. Yes, multiple blocks. Depends on multiple blocks. Yes, depends on capacity of disk dividing the number of multiple blocks here. Any file system, in any file system, hard disk divides into multiple blocks. Okay. So what is block? Let us see. What is block? Let me take hard disk here. Suppose this is disk. So this is hard disk. Let us, this is hard disk. Hard disk. Yes, hard disk. All the blocks. So this is block 1. So this is block 1. Okay, next block 2. Yes, next block 3. Next block 4. Yes, like this multiple blocks here. Sub to number of blocks. This number of blocks depends on size of disk, capacity of disk. Capacity of block n. Last one. Yes, some block n. Block n, right? This number of blocks depends on, yes, capacity of disk. Okay. Now here, what is size of each block? Yes, what is size? What is size of each block? What is size of each block? Let us see that. Yes, question is what? Yes, these are basic questions. Yes, in Hadoop, what is size of each block? Yeah, the size of each block. What is size of each block? Yes, size of each block. Size of each block. Size of each block depends. So this is depends on file system. Depends on file system. Depends on file system. The size of each block depends on file system. Yes, here traditional file systems. In traditional file systems. Yes, in traditional file systems like Windows, Linux. Yes, in traditional file systems like Windows and Linux file system. On Linux file system, yes, size of each block. Size of each block is equal to 4 KB. It's a 4 KB. Yes, traditional file systems. Yes, in traditional file systems like Windows and Linux file system. Yes, size of each block is equal to 4 KB. Yes, so this is 4 KB disk, 4 KB, next 4 KB, 4 KB, next 4 KB, 4 KB like this. So all the blocks with 4 KB. So capacity with 4 KB. So next 4 KB. So next 4 KB like this. Yes, all the 4 KBs. The disk divided into multi blocks. So each block 4 KB, right? Like the disk divided into 4 KB, 4 KB like this. So all the 4 KB, 4 KB like this. So 4 KB, 4 KB like this. So size of each block is 4 KB, right? So size of each block is 4 KB, 4 KB like this. So this is traditional file system. Suppose, for example, some file created. Yes, in traditional system, some file 1 created. For example, file 1 created. So this data storing into first block, starting the first block. Okay, suppose file 1 this is. Next block, yes, file 1. Suppose if not enough, using next block. If not enough, using next block. Okay, if not enough, using next block like this. Suppose this file 1 stored on this much of blocks. Next, another file. Yes, one more file. File to create it. One more file. Another file created. File to create it. File to create it. So this file to, yes, next blocks. Next empty blocks. So this is next empty. File to. Yes, file to. Yes, next empty. File to. So next empty. Yes, file to. Yes, next empty. Yes, file to. Yes, if not enough, looking for next empty. So next empty like this. File to like this. Suppose one more file created. Next file, file 3. File 3. Yes, next empty. File 3. So next empty. Yes, next empty like this. Suppose next file, one more file, file 4. Yes, next one more file, file 4 here. Like this, next empty. Okay, next empty like this. Okay, yes, file. Suppose next file 5 like this. File 5. Yes, file like this. Okay, right? So this is yes, that, yes, filling like this. Okay, so 4 KB like filling all these disk like this, right? Okay, suppose for example here, file to delete it. File to delete it. When file to delete it here, all the blocks becomes empty. File to blocks. Now these are empty. These blocks becomes empty. Once file deleted, those blocks becomes empty. Next, one more file created. Suppose file 6 created. Yes, using this blocks. File 6 created. Next, using this blocks. Okay, maybe 2 blocks enough. Just using this, right? Suppose next one more file created. Suppose file 7 created. Yes, file 7 created. So next using this blocks. File 7, right? File 7. Okay, suppose, yes, file 7 like this. So using 3 blocks. Suppose one more file created. Suppose file 8 created. File 8 like this. Suppose if not enough here, file 8, 2 blocks is right. If not enough, using looking for next empty block. So this is next empty block, right? File 8, next empty block. So next empty block, file 8 like this. Not enough, next empty block, right? Like this. Next empty like this. Okay, right? Yes. So next time, suppose file 7 deleted. File 7 deleted. These blocks becomes empty. File 7 deleted. These blocks becomes empty. Okay. Yes. Next. File 3 deleted. These blocks becomes empty. So file 7 deleted. Those blocks becomes empty here. File 3 deleted. These blocks becomes empty here. Okay. Fine. Yes. What is happening inside of disk is like this. Suppose next one more file created. Suppose file 9 created here. File 9. So first empty block. Storing into first empty block. If not enough, next empty block. Not enough, next empty block. Not enough, next empty block. Not enough, next empty. Not enough, next empty. If not enough, next empty. If not enough, next empty. Next empty like this. Okay. See file 9. See different locations, right? File 9. Here, file 9. So file 9. Okay. Next here, file 9. Okay. Next here, file 9, right? Like data storage like this. That means randomly storing. It's not a side by side. Randomly in this block, next in this block, in this block. Next jumping to this block, right? This block, this block, this block. From this jumping this block, right? This is. So randomly storage, right? Okay, randomly file name. These are the blocks allocated for the file name here. So first block, second block, third block, fourth block, fifth block, sixth block, seventh block, eighth block, ninth block, right? Yes, every block will have some address. Okay, every block will have some address. That address links to file 9 here. File 9 and its blocks. Yes, just file 9 its blocks. Okay, so here block, this block address, next block address, next block address. So all the blocks addresses link it to file 1. Okay, link it to file 1, right? That concept is a FAT concept, file allocation table. That concept is called as FAT, file allocation table. FAT concept in traditional file systems. Okay, FAT, file allocation table. That file allocation table contains yes name of the file and address of each block here. Address of each block. So data storage always is random process, randomly storing here. Randomly storing. Just storing random, right? It's a random process. Yes, here data storage always randomly here. Storing data in a randomly here. It's a random process. Right, okay. Suppose when you try to see the file data, now collecting data from the disk, right? Collecting data. So collecting first block here, second block, third block, yes, next fourth block, yes, collecting from the yes these things, right? So there is data processing here. Data processing always sequential. First block, second block, third block, fourth block, fifth block, like this, one by one. First one, after this next block, after this next block, after this next block, after this next block, like this. One by one picking this, right? It's a sequential process. Okay. So here data storage. Yes, here data storage. Data storage. Yes, data storage. Data storage is always is a randomly here. Data storage is always randomly here. Randomly storing data in the disk here. Data storage is a randomly in the disk here. In the disk here. But data processing is a sequential data processing. Sequential, not randomly here. Data processing is sequentially here. Sequential data processing. It's a sequential. Okay, data processing is always is a sequential. Okay, data processing is always yes sequential data processing here, like one by one here. So first reading from the first block, next block, like this. So data processing is always is a sequential data processing. Sequential, yes, data processing is always is a sequential data processing here. Sequential data processing is a sequential, but data storage randomly. So randomly, wherever that empty block available, they're storing here. Data storage always randomly, but data processing is sequentially here. So this is traditional system. Disk is like this. So hard disk divides into multiple blocks. Size of each block is 4 KB, 4 KB, like this. Next, data storage always randomly, but data processing is a sequential data processing. First picking first block data, after picking next block data, next block data, next block, like this. So picking first block data, second block data, third block data, fourth block data, fifth block data, like this. So picking one after another one is not randomly. Suppose picking first block and maybe third block, maybe fifth block, maybe yes eighth block, like this. Not like that. Not randomly picking here. Random, yes, it's a sequential. Picking first block, second block, next third block, next fourth block. So here first reading first block data, second block data, third block data, fourth block data, fifth block, like that, like this. So one after another one. So data reading is always data processing is always is a sequential, means one after another one. It's a sequential, but storage randomly here. So wherever that empty blocks available, they're storing data. So data storage always is randomly here. Data storage always randomly in the disk here, Okay, but data processing is always, it's a sequential. Data processing is always yes in sequential manner here. Yes, in sequential manner. Right, okay. So this is data storage, data processing on the disk. So we have a traditional system. Okay, now come to HDFS. Yes, Hadoop. HDFS. What happens in HDFS? Let us see here. Yes, in HDFS. Okay. Yes, in HDFS, size of each block. So what is size of each block here? In HDFS, size of each block. So this one depends on Hadoop version. Okay. So in HDFS, size of each block depends on Hadoop version. Okay. Yes, Hadoop. There are two versions here. Sorry, three versions. Hadoop 1.x version. Next Hadoop. Yes, Hadoop 2.x version. Yes, next Hadoop. Yes, 3.x version. Hadoop 3.x version. There are three versions in Hadoop here. Hadoop 1.x version, 2.x version, and 3.x. 3.x just recently released, but no one using 3.x. So all the companies are using 2.x. Yes, our topic is completely on 2.x. Okay, 2.x we are going to discuss. Okay, yes. So size of each block depends on Hadoop versions here. Yes, Yarn comes under Hadoop 2.x version. Yarn concept is a Hadoop 2.x version. That time we'll discuss. Yes, in 1.x version. Yes, in 1.x version, size of each block. Yes, size of each block is equal to size of each block. Size of each block is equal to, yes, 64 MB. So this is default. This is default. So default size of each block is 64 MB. Try to remember this. These are all the entry questions. In Hadoop 1.x version, yes, in Hadoop 1.x version, yes, size of each block. Yes, in Hadoop 1.x version, size of each block. Size of each block is equal to size of each block 1.x version. Hadoop 1.x version, size of each block equal to 64 MB. It's a default. Default. Yes, it can be configured. Yes, it can be. Yes, it can be. It can be configured. Yes, we can change that size here. It can be configured up to. It can be configured up to 128 MB. It can be configured up to 128 MB here. Okay. Yes, in 1.x version. Yes, in Hadoop 1.x version, size of each block equal to 64 MB. It's a default. It's a default. Okay, it can be configured up to 128 MB here. Okay, so this 1.x version. Next, in 2.x version, yes, 2.x and 3.x same. Yes, 2.x and 3.x both are same here. Yes, in 2.x version and 3.x version, size of each block is equal to 128 MB. 120 MB is double. It's a default. Default. Yes, this can be configured up to 256. Yes, we can change that size here. Size of each block. Yes, it can be configured up to 256 MB. We can make it 256 here, right? Okay. So the size of each block. Size of each block is 128 MB here. It can be configured up to 256 MB here. Okay, right? Yes, just is a double here. Yes, in 1.x version, Hadoop 1.x version, size of each block equal to 64 MB. It's a default. Yes, in 1.x version, size of each block equal to 64 MB. It's a default. Default that can be changed. Yes, it can be configured up to 128 MB. Up to, just we can make it double. Just we can make it double of this 128, but we can't make it 256. 64 MB can be 128 MB here. That is 1.x version. Yes, when come to 2.x version here, yes, 2.x version or 3.x. In any case, in both cases, yes, size of each block equal to 128 MB. It's a default. It's a default. It's a default, right? Yes, it can be configured. It can be configured up to 256 MB. Okay, right? Yes. Now here, this is size of each block is, yes, 128 MB. Default size of each block. Yes, here we are using 2.x version. Okay. Yes, when you put up the experience, you should put up the experience on 2.x version. So when asking that question here, yes, what is the size of each block? Default 128 MB. Suppose someone is asking for 1.x version, then you have to explain this one here. 64 MB. 64 MB, right? Okay. Yes. Here 1.x version default is 64 MB. That can be made as, we can make it as 128 MB. Yes, in 2.x version, size of each block equal to 128 MB. Yes, in Hadoop also, data storage same. Disk divides into blocks. Okay, storing into multiple blocks, right? File storing into multiple blocks like this. Yes, what is size of this block? Size of this block is equal to 128 MB here. This block size is equal to 128 MB here. In traditional file system, 4 KB, 4 KB. But in Hadoop, it's a 128 MB, very big size, right? Yes, 4 KB and 128, nowhere comparison, right? Yes, where is 4 KB and where is 128? 120 MB, right? Yes, how many 4 KBs? 4 KBs becomes 128. So many things, right? Many, yes, many blocks for this. So here designed large size to handle big data here. Yes, maybe asking this question here. Why block size design so large? 128 MB. That topic we'll discuss next. Yes, in cluster I'll explain this. Okay, yes, here Hadoop is designed for the big data handling, big data processing, to store and process big data. For that purpose, 128 MB. Okay, so why 128 MB? Why design so large? The topic we'll see next. We'll see next. Next the coming topic in cluster I'll explain that. Okay. So in traditional file system, size of each block is 4 KB. Yes, but here is a 128 MB. Right, okay. So that is the difference here. 4 KB, 128 MB. Right, okay. Yes, now let's come to HDFS. Yes, suppose file one. This is a file one. File one with yes 100 GB data. File one with 100 GB data. For example, let us take file with 100 GB data. Now this file loading the cluster. So for this purpose, first of all, this file one splitting into multiple blocks. Yes, 100 GB is equal to yes 100 GB is equal to how many blocks? 100 GB is equal to how many blocks? Let us see this. 100 GB equal to how many blocks? That is the question here. 100 GB is equal to how many blocks? Yes, one block is equal to how much here? 128 MB, right? 128 MB. Okay, now let us see 1 GB. 1 GB equal to how many blocks? 1 GB equal to yes 1024 MB, right? 1024 MB. So you get 1024 MB divided by 128 MB, right? So 1 GB equal to 1024 MB. So number of blocks. Now number of blocks here 1024 MB. 1024 divided by 128 MB. So this 1 GB, it's a 1024 MB here. 1024 MB divided by 1 block size 128 MB, right? Get this value is equal to how much? 8 blocks, right? 8. Yes, see this 800 8 into yes 20 960 plus yes 64. So 1024, right? So this value is equal to 8 blocks. 8 blocks, right? 8 blocks. 8 blocks of data, right? Okay. So this is a 2.x version. Suppose 1.x is how much here? 16 blocks. Okay. Now here 1 GB data is equal to 8 blocks, right? Then 100 GB data. 100 GB data is equal to how many blocks? How many blocks? How many blocks? Let us see that. Yes. So here 100 GB data is equal to how many? 1 GB data. 1 GB equal to 8 blocks, right? Okay. So 1 GB. Yes, 1 GB is equal to 8 blocks. 1 GB equal to 8 blocks, right? So 1 GB equal to 8 blocks. 1 GB equal to 8 blocks here. Then 100 GB data equal to how many blocks? Then 8 into 100, right? So 8. Yes. Into 100, right? Yes, 100 GB. 1 GB equal to 8 blocks. That means 100 into 8 blocks is equal to 800 blocks, right? 800 blocks. 800 blocks, right? Okay. So 1 GB, 100 GB data divides into 800 blocks. So first data dividing into multiple blocks. Data dividing into multiple blocks. So here in Hadoop, first of all, file divides into multiple blocks, then storing on different blocks in the cluster. Okay, right? So here file one, suppose file one, yes, with 100 GB data. This 100 GB data, yes, converts into 800 blocks. Yes, after dividing into 800 blocks here, those 800 blocks distributing onto multiple nodes in the cluster. Yes, let us see how the distribution takes place. The distribution, data distribution. Okay. Yes, data distribution. Yes, all the 800 blocks. Yes, all these 800 blocks. 800 blocks. Yes, distributing these 800 blocks, distributing onto multiple nodes. Yes, multiple nodes in the cluster. Multiple nodes in the cluster. Multiple nodes in the cluster. Yes, all these 800 blocks distributing onto multiple nodes in the cluster. What is node? Node means computer. Yes, node means computer. Node means it's in Hadoop terminology calling as node here. It's just like our computer. Node means just like our computer. Okay. So what is our computer? Our computer contains what? Hard disk and RAM memory, motherboards and all this, right? Same. Yes, in Hadoop terminology is a node here. Yes, each and every computer called as node. In Hadoop it's a node. Node means computer. Okay. Yes, all these 800 blocks distributing onto multiple nodes in the cluster. So node means it's a computer, right? Okay. Yes, what is cluster? Now let us see Hadoop cluster. Okay, cluster. Yes, let us see high level architecture. First, let us see high level Hadoop cluster, high level architecture. High level architecture. Let us see high level architecture so that you can understand the distribution or data distribution. You can understand here. Hadoop high level architecture. Next, low level architecture later we'll discuss. Hadoop high level architecture. Yes, Hadoop, it's a Hadoop architecture. It's a master and slave architecture. Yes, it's a master. Yes, master and slave. It's a master and slave architecture. Master and slave architecture. Master and slave architecture. It's a master and slave architecture. Okay. Hadoop is a Hadoop architecture. It's a master and slave. It's a master and slave. So what is master? What is slave? Let us see. Yes, master, there is a node called some name node. It's a master. Yes, let me take some text marks for easy understanding. Yes, this is a master. Yes, master node. So this is master. Yes, name node. Yes, name node is called as master here. It's a master. So this is master node. It's a master node. So this is master. So this is master node. This is master node. Now it's a master node, right? Just it's a master node. Okay. It's a master node. Yeah, this is master node. So this is master node, right? Okay. Master node. Next slave nodes. Master and slave here. So this is master. This is master node. Yes, name node called as master. Next slave nodes. Slave nodes. Yes. So this is data node. Data node. Yes, data node 1. So this is slave 1 and slave 2 data node. Yes, data node 1, data node 2, data node 3, like this, multiple data nodes. Next slave node. Yes, next slave node. Next node like this. So data node 1. Okay. Yes, data node 2. Data node 1. Data node 2. Yes, next. Okay. Yes, data node 1. Data node 2. Data node 3. Next data node 4. Next data node 5. Data node 6. Yes, data node 7. Like this, multiple data nodes. Data node 1, data node 2, data node 3. Okay. Next data node 4. Yes, data node 5. Data node 6. Okay, next. Like this, multiple data nodes. Data node 6. Yes, next. 7, 8, 9, 10, up to multiple data nodes, up to data node n here. This number of nodes depends on cluster, depends on size of data, depends on volume of data. See, every data node communicates with name nodes. This is communicating name nodes. Okay. Next, this also communicating name nodes. Next, this is communicating with name nodes. This is communicating with name nodes. Yes, it is a network, completely Hadoop network called as Hadoop cluster. Yes, all the data nodes, every data node communicates with name nodes. Just to communicate name node, right? Yeah, this is called as master here. This is called as slave. So it's a slave computer. This is called as slave here. Yes, master and slave architecture. So this is slave. These all the nodes are slave nodes. These are slave nodes. These all are slave nodes. So these all are slave nodes. These all are slave nodes. These all are slave nodes. Yes, it's a master and slave architecture. It's a master and slave architecture. Yes, all these are called as slave nodes. All these are slave nodes. Here, okay, these are slave nodes. Now this is master nodes. That is a master node here. Yes, it's a master and slave architecture. This is master. This is master. So this is master and slave here. So this is master. So this is master and this is slave here. So it's a master and slave architecture. Yes, Hadoop is a master and slave architecture. Yes, what is master here? Yes, master. Yes, is like a manager. Is like a manager in company. In company. So master is like a manager in the company here. Master, it's like a, yes, master is like a manager in the company here. Yes, what is slave? Slave is like a, yes, employee or worker. Employee in a company. In a company, yes, master is like a manager in the company here. Slave is like a employee, yes, in the company here. Right? Okay. Yes, here. Yes, the company manager always gives the instruction to the employees, right? Yes, the employee has to work as per the instructions from the manager, right? So manager always giving instruction to the employees. Yes, employees have to work. Employees have to work as per the instructions from the manager, right? Same concept here. Yes, name node. Name node always giving instruction to data nodes. So as per the instructions from name nodes, all data nodes have to work. So this is master and slave architecture, right? Okay. So first here, data distribution. How data distribution takes place? Yes, let us say about data distribution. How data storage in the, yes, cluster. Data storage. See, data storage. Suppose for example here, that request. Yes, every request goes to name node. Maybe data storage request, data loading request, or mapped job submission request. There are two things in this. In Hadoop cluster, yeah, there are two things. So first one, data loading request, data loading. There are two jobs in Hadoop here. Data loading request, okay, data loading request or job submission request. Data loading request or job submission request. Job submission request. Data loading or job submission request. Okay. So job submission, this comes on data processing. Second topic, second big data challenges. First one data storage, next one data processing, right? So this is comes under data processing here, not data loading request. Okay. Yes, only two things. Only two tasks in Hadoop here. Yes, only, yes, here only, yes, only two tasks in Hadoop. Yes, only two tasks in Hadoop here. So first one is data loading, second one data job submission request. Okay, only two tasks in Hadoop here. So first one is data loading task here, next is job submission task, right? Only these two things. So data loading request. Yes, this is comes on data storage. Job submission request comes on data processing. Data processing next, tomorrow topic. Data loading request. So here, so first request, every request, yes, every request goes to name node. Okay, every request simply goes to name node here. Every request, yes, every request simply goes to name node. Every request goes to name node here. Okay, maybe data loading request or job submission request here. Okay, so data loading request, data, yes, loading or job submission or job submission. With job submission, right? So request, data loading request or data loading or job submission request simply go to name node. So name node receiving all the requests, right? Name node always receives the request here. Every request goes to name node. Name node is a central controller. Name node is a central controller in the Hadoop architecture. Yes, always request goes to name node. So data loading request or job submission request. Now here is a data loading request. So data loading request simply goes to name node. Okay, data loading request goes to name node, right? So for example here, yes, file one file one with, yes, file one with 100 GB data. File one with 100 GB data. So data loading request, right? Yes, loading into Hadoop cluster. Hadoop cluster. How this will be loading here? Okay. So file 1 with 100 GB data loading into Hadoop cluster. Yes, how this loading process, how this processing takes place here? Yes, let us see that. So first request goes to name node. So name node taking file 1 with 100 GB data. So name node takes all the 100 GB data, divides into multiple blocks. Okay. So here data loading request. Yes, data loading request. Yes, data loading request. So data loading request taking by name nodes. Okay. Yes, data loading request simply here. Data loading request simply goes to name nodes. On receiving data loading request here. Yes, on receiving. Yes, on receiving data loading request here. Data loading request. Then name nodes. Name nodes. Yes, divides name nodes. Divides file data into multiple blocks. Divides file data into multiple. First of all, name nodes. Yes, name node taking the data loading request. Suppose file 1 with 100 GB data, that request got name node. On receiving data loading request, name node divides file data into multiple blocks. File data into multiple blocks. Okay, just yes, divides the file data into multiple blocks. Okay, after dividing into multiple blocks here, multiple blocks, and distributing onto multiple nodes in the cluster, or distributing onto multiple nodes in the cluster, multiple nodes in the cluster, multiple nodes in the cluster means Hadoop network, multiple nodes. Yes, where this data storing here in data nodes. Yes, name node is to take the request. Okay, data node is to store the data here. So name node taking that file 100 GB data, dividing into that 800 blocks. Name nodes 100 GB data divides into how many blocks here? Yes, 800 blocks, right? 800 blocks. The data becomes 800 blocks, right? So name node taking 100 GB data divides into 100 blocks. After dividing into 100 blocks, yes, it will try to distribute on multiple nodes in cluster. It will distribute that 100 blocks into multiple nodes in cluster. Yes, how the distribution takes place? Let us see this. Suppose in node 1, suppose 100 blocks free space available, then using that 100 blocks. Okay, suppose data node 2, yes, no space. Suppose no space available here, then looking for next node here. Yes, suppose no space. Yes, on second node, no space, then looking for third node here. Suppose in third node, suppose 200 blocks of space available, using that. Suppose node 1, 100 blocks. Okay, node 2, yes, no space. Suppose in node 2, no space, yes, then go to third node here. In third node, maybe 200 blocks. Suppose next node, maybe 150 blocks of space available. Yes, suppose depends on space available here. Suppose here 50 blocks of space available. Next node, maybe 120 blocks. Like this, distributing on multiple nodes. Those 800 blocks. Okay, those 800 blocks distributing onto multiple nodes in the cluster. So you get 100 blocks, next 200 blocks, next 150 blocks, and 50 blocks, 120 blocks, next like this. Like this, depends on space availability here. Yes, distributing onto multiple nodes. So first 100 blocks here, next 200 blocks, next 150 blocks, next 50 blocks, next 120 blocks, like this. Like this, yes, the data storing and multiple nodes in cluster. That 800 blocks are distributing onto multiple nodes in cluster. Right? Okay. So done, completed. Yes, file one loading completed. Next file, loading next file data. Yes, next file also distributing onto multiple nodes in cluster. Depends on space availability. So next nodes, next one, like this continuously distributing. Yes, any file always distributing on multiple nodes in cluster. 1 second. Suppose 100 GB data, file size 100 GB. Suppose in node 1 itself, yes, for example in node 1, 1 TB free space available. For example in node 1, 1 TB free space available. I'll assume that. Yes, in node 1, first node itself, 1 TB free space available. But what is size of file here? Only 100 GB data. So this 1 TB free space is more size, right? Yes, more free space available. Yes, on node 1 itself 1 TB free space available. Yes, now file 1 100 GB, 100 GB. Yes, will it store into first node or not? Now your question is, on node 1 itself 1 TB free space available, but that incoming file rate is only 100 GB. 100 GB. So in 1 TB free space we can store 100 TB, 100 GB, right? Yes, we can store. Now here, so file size of the file is 100 TB here, 100 GB. Size of the file is 100 GB, but inside of node here 1 TB free space available. Yes, in that scenario. Yes, will it this store into this first node or not? No, it won't store. Yes, this node is capable of storing 100 GB because of yes 1 TB free space available, right? 1 TB free space available. Even 1 TB free space available, never storing the single node. Never storing the single node here. Yes, always if you try to distributing on multiple nodes in cluster. Okay. So here 100 GB data, always if you try to distributing onto multiple nodes in cluster. Reason we'll discuss next. Tomorrow topic that is. Reason tomorrow topic like this. Okay. So even 1 TB free space available, even more free space available here, it won't store on the first node here. It will try to distribute on multiple nodes in cluster like this. Okay, so like this, it will try to distribute on multiple nodes in cluster like this. So this is distribution concept, right? Okay. Yes, data storage like this, data distribution like this, right? Okay. Yes, still this topic not yet completed. Yes, almost time is now 1 second. Let me check time. Yes, 11:35. Yes, tomorrow will continue. Yes, tell me what's your doubt? Hello. Hello.
Hello. Hello.
Yeah, tell me.
Sir, my question is that which project we are going to take it as a live project? I mean, can you tell me the brief so that I know, I mean, in the end of this course,
At the
what
end
would be
of
the
the
project?
course, I'll explain about medical data project.
Okay, sir. Okay.
Okay, right? Yeah. So
Okay.
tomorrow,
Okay, sir.
okay, right? Let us wind up for
Yes,
today.
sir.
Already
Okay. No.
11:35. Tomorrow will
Okay. Okay.
continue.
No issue. Okay, sir. Thank you.